Welcome to my video on similar figures involving practical problems. So today we're going to look at real-world problems that involve similar figures. So similar figures can be used in real-world applications in the areas of art, engineering, surveying, and more. Indirect measurement is the technique of using similar figures and proportions to find the length, width, or height of an object that would be difficult to measure directly. For example, a building or a large tree. One type of indirect measurement, called shadow reckoning, uses the shadow lengths of two objects and the actual height of one of the objects to set up a proportion in order to determine the height of the second object. When solving a similar figure practical problem, it is helpful to draw a picture. Okay, so when we solve the ones in our notes here, we are going to draw a rough picture or a sketch to help us see which sides match up. So let's look at our first example, and the picture is already here for us. A person who is 6 feet tall casts a 5-foot shadow. At the same time, a flagpole casts a 10-foot shadow. How tall is the flagpole? So we know that the person is 6 feet tall and casts a 5-foot shadow. So you can see the picture. Here's a 6-foot tall person and a 5-foot shadow. At the same time, a flagpole casts a 10-foot shadow. And here's the 10-foot shadow. How tall is the flagpole? So here's the height of the flagpole. We can set up a proportion and solve to find the missing side. So we're going to call that X. And I already have a template set up here. Now this isn't the only way to do it. We can talk about the other ways. But the one I chose here is the shadow of the man over the shadow of the flagpole. So we can do shadow over shadow. So I'm going to go circle these, and I'm going to go 5 over 10. And then, because I put the shadow of the man on top over the shadow of the flagpole, I have to put the height of the man on the top. I can't flip-flop them. So I got to go man over flagpole, man over flagpole. So the height of the man is 6 feet. So we're going to box this in, and we're going to box in the height. I have a question mark there, so we're going to call that X. So now we can use the cross product. So 5 times X is 5X. And remember, cross products are equal, so we're going to set that equal to 6 times 10, which is 60. And the opposite of multiplication is division. So we're going to divide both sides by 5. 5 divided by 5 is a 1 in disguise. So bring down your X, bring down your equals, and 60 divided by 5 is 12 feet. And is that reasonable? Yes, because the shadow height doubled, so the height of the shadows doubled, so the height of the flagpole doubled when compared to the person. Okay, now let's talk about another way we could have done it. We could have done shadow over height, so man's shadow over man's height, and we could have done shadow over height, so 5 over 6 and 10 over X. And let me just show you what that would look like. You don't have to write that, but we could do 5 over 6 and 10 over X. And notice what number is still diagonal to the X, the 5 and the 10 and the 6. So it's going to give us 12 once again. So let's circle our answer, and let's turn the page. Okay, so once again, we said draw a picture. The first one was drawn for us, so this time we are going to draw our own. And it says a tree casts a shadow 9 meters long. At the same time, a building 54 meters tall casts a shadow 21 meters long. To the nearest meter, that means to the nearest whole number, what is the height of the tree? Now, you could just draw sticks to represent the tree and sticks to represent the building if you're not a good artist. I'm not a good artist, but I do happen to know how to draw a tree, so I am going to draw a tree. It's not a great tree. And we know that the tree casts a shadow of 9 meters. And we want to know the height of the tree, so I'm going to put X there. And then for a building, okay, there's my building, and it casts a shadow of 21 meters, and the height of the building is 54 meters. Okay, now I can do this several different ways. I can pair up corresponding sides, or I can pair up height over shadow of the same figure. So what I'm going to do is I'm going to pair up height of the tree over shadow of the tree. So I'm going to go height over shadow. And because I did height over shadow over here, I have to do height over shadow. I can't do shadow over height. So I'm going to box in the 54 and box in the 21, and I'm going to write 54 over 21. Okay, circle the number diagonal to the x, and 21 times x is 21x. Proportions are two equal ratios, so these are going to be equal to the cross product of these. So 54 times 9 is 486. I'm going to need to solve for x, so divide both sides by 21. 21 divided by 21 is a 1 in disguise, so x equals. Now, when I typed this into my calculator, I got 23.1 something, something, something. So to the nearest meter, 23.1 is closest to 23 meters because it said round to the nearest meter, or it said to the nearest meter, what is the height of the tree? Okay, so let's look at number 2. Hannah is on the yearbook staff. She has a photo that is 8 inches wide and 10 inches in length that she wants to put in the yearbook. She must reduce its size so that it will fit in the space that is 2 inches wide. What will the length of the photo be in the yearbook? So let's underline the important pieces of information here. The photo is 8 inches wide and 10 inches in length. And she's going to reduce its size to 2 inches wide. What will the length of the photo be in the yearbook? So I'm going to draw the initial picture here of it's 8 inches wide and has a length of 10 inches. And then she's going to reduce it, the width to 2 inches, and we want to know its length. Okay, so in the last one, I paired up the two lengths of the same picture. I did height over shadow. So in this one, it would be 10 over 8, x over 2, but I'm going to show you the other way, which is corresponding sides. So I can go 10 over x, and then this width corresponds to this width, so equals 8 over 2. Circle the number diagonal to the x. 8 times x is 8x, and 10 times 2 is 20. I need to get the x by itself, so I'm going to divide both sides by 8. 8 divided by 8 is a 1 in disguise. 20 divided by 8 is 2.5 or 2 and 5/10 inches. So I always have to make sure I have a label here. Okay, let's move on to the last and final example here. It says a 12-foot ladder leans against a building. The top of the ladder touches the building 9 feet above the ground. How far above the ground would a 16-foot ladder touch the building? Assume that both ladders form the same angle with the ground. Okay, so I know the ladder leans against a building, and it's a 12-foot ladder. And I know that the building's height is 9 feet. And then it says how far above the ground. So I'm going to draw another building. Would a 16-foot ladder. So there's my 16-foot ladder, and I'm looking for the height. So this time I'm going to go height of building over ladder. So I'm going to go 9 over 12. So circle those two. So we're going to write 9 over 12. And then I'm going to go height of building. So I don't know it. I'm going to put x over the length of the ladder, which is 16. So now I'm going to use cross products. 12 times x is 12x. That is going to equal 9 times 16, which is 144. The opposite of multiplication is division, so I'm going to divide both sides by 12. 12 divided by 12 is a 1 in disguise, and 144 divided by 12 is 12. So it's 12 feet. And that is a reasonable answer because the height of the building is less than the ladder here, so the height of the building here must be less than the ladder here if they're similar figures, which they are. Okay, that concludes, and we know they're similar because it says that they're forming the same angle with the ground. Okay, now that concludes our notes on similar figures with practical problems. Be sure when you do your classwork and your homework that you are using the strategy of drawing the picture. That will be helpful. I hope you have a great day.